Okay. Sorry, that was kind of even loud for me. Why don't we get going here in the chemistry building. So is that catering okay? Is everybody happy? We spend a little extra money on that to make it better than it could be. I was telling people in the break that we didn't used to do that. It was like a few years there in the beginning. And then well, the whole thing kind of operated at a loss when it started. Well, anyway, it doesn't matter. I don't have to give you the whole history of the financial aspects of this thing. But yeah, we definitely have upped the catering a bit, which is good. Oh yeah, and the restrooms, it turns out, are just right through that door. So you don't have to go that one at all. If you need to get there in a hurry, it's through there. And they've got one of those Dyson hand dryers. Aren't those awesome? Those things. You don't have to use you're not sitting there waiting an hour for the thing to dry your hands. Those Dysons. I had these, some cleaners at one point came to my house. I don't have to put it like that. We have cleaners. They come every 2 weeks. I'll just say it. We've got children, and we have cleaners, and we pay the money, and we're much better off for it. I'll just put it out there. I'm not gonna lie. Then, and it was funny because the first time we did it, like, you know, you feel kind of guilt and you feel weird, and it's like this whole strange. Anyway, and these people came in, and I was like, oh, you know, this is the house or whatever, and the person leaned in, and she said, she was with her partner, and she said, do you have a Dyson? And I was like, a Dyson vacuum? She's like, yeah, do you have one? We love those. And I was like, I'm sorry, I don't. I don't know what it is, but it's not that. She was like, oh, all right. But now you know why. Like, you go to that thing, and anyway. And it's just a vacuum reversed, so it's probably not that hard for them to do. Anyway, okay, let's get going. So let's talk about Mplus, what it can do, and some of the capabilities that it has that we won't use in the next 5 days, but that you will have access to as long as you know some basic input functions, which are going to be really easy, things like on, with, and then a few other things, and then you can take advantage of a wide variety ofMplus's features. Amazing features. Sunday, come on down. So people ask me, I guess, after these descriptions, do I make any money off of Mplus, or do I get a cut or something like? No, I'm not affiliated at all. I don't have. Somebody asked me, they're like, do you have to pay for Mplus? I was like, actually, I do. Maybe I should bring that up. Anyway, no, I know they're so good at what they do, they can justify running a business. Yeah, exactly. So let's talk about the Mplus team first. I want to tell you, if you start using Mplus a lot and engaging with the written material about Mplus and its authors, etc., then who you'll be dealing with. So Mplus is the original author of Mplus and is former president of the Psychometric Society, and was a student of Joreskog. So if you've used Listerol, then you might know who Joreskog is. And Joreskog was Bank's advisor. And I think Bank did a fair amount of work in some of the original algorithms that Listerol used. This is a bit gossipy. I probably shouldn't say it into the lecture capture, but I'm pretty sure that's true. And eventually started his own software package, and which is today Mplus. So he has a PhD in statistics, and he co-owns Mplus and runs it with his wife Linda, and she has a PhD in educational statistics. And another part of that team is Tihomir Sperohov, who I think I'm saying that correctly. I've heard him say it. and then I can't say it after I hear him say it. So, but I think that's pretty close. And he has a PhD in statistics from Caltech and a very cool Russian accent. I'm sure he plays chess. He's got this little kind of nerd fantasy of the Caltech PhD Russian. Anyway, whatever. And here's the cool thing about this group of people is that you'll interact with them on a regular basis in a couple of different ways if you really start using Mplus and engaging with it and some of the resources that it makes available to you. One of those is a great message board at statmodel.com, which is their website. And that message board has thousands and thousands of posts on all kinds of topics. And so if you want to know how something works in Mplus, odds are that it's in there somewhere. So you can go to statmodel.com, go to the message board. It's organized by topics, and you can just never be seen again. You can just spend the rest of your life doing that. But it's also got a search function. So if you're looking for something specific, you can search for it. Because odds are someone has already asked probably a question you have. So that's one way to engage with them. And another way is if you're having trouble with Mplus, I don't want to be too liberal with this recommendation because I think Linda and Bank, they get a lot of emails. But if you've purchased Mplus and you're buying the regular annual subscription, then you have access to their email help, which is support@statmodel.com. You can say, it looks like Mplus isn't working properly. I can't figure out why. Is that a problem with the program? Odds are it's a problem with you. It's always a problem with me. Maybe 2 or 3 times have I ever, over 10 or 15 years, ever found a bug in Mplus. And I'm always like, oh my God. It's like, but it's very rare. It's extremely rare. And then it's a silly thing to take a little bit of pride in. It's stupid. But anyway, you can email them and say, it looks like, I can't understand why it's giving me this output. I'm asking it to do blank, but it's not, etc. And they can help you there. That is an incredible resource. They are so helpful and so professional. Anyway, so those are the people who you'll be probably interacting with. And those are the people who have written papers on Mplus too, right? So, etc. So let's talk about Mplus, or just give a brief overview of what it is and how it works. Here's all Mplus is really doing. One way to think about it is that it's just solving for unknown terms, unknown parameters in regression equations. That's one way to think about it. It's the simplest way. SPSS does that, Stata does that, SAS does that. That's all any of these programs are doing. They're just giving you estimates of something that you don't know and you want to know. You're going to give it data, and based on the data it says, oh, this is the parameter estimate based on the data, whatever that is. So maybe it's a regression coefficient, it's a slope, rise over run, right? It's going to give you that estimate. That's really all it's doing, is it's solving for unknowns in your model, your statistical model, given the data that you have. Or by drawing on the information contained in the data. So what is it really doing? Well, if you have all observed variables in your model, or what some people call manifest variables, observed variables, data that you've got for these variables, then it's path analysis and traditional regression. That's what it is. That's Mplus is solving for unknowns in regression models. If you've got continuous latent variables, which we'll start working with on Wednesday, something that you haven't observed directly, the classic latent variable in psychology is G, or intelligence. That was kind of Spearman's original formulation of a latent variable and the basis for exploratory factor analysis. He wanted to work with that. It's not directly observed, right? Psychologists have a ton of these things that aren't materially, they're not directly measurable. They're in the mind. So your subjective well-being and all kinds of stuff, right? Emotional states, etc. So those can all be conceptualized as latent variables. And they're continuous if they continuously vary. You might be a little more well off than I am subjectively, or a lot more, or whatever. And if you're working with continuous latent variables, then you can actually be doing a couple of different things. One is structural equation modeling. That involves latent variables, as we'll see, continuous latent variables. And the language that we'll use there is we'll call those latent variables factors. But it's just a latent variable. And it's just regression with latent variables. Or you could be doing multi-level modeling. And we'll see this is kind of interesting, that actually a similar logic applies. It's a bit different, but you're still just working with continuous latent variables. Or random effects or hierarchical linear modeling. Those are all the same thing. Multi-level modeling is the general term that we'll use for that. And there we'll work with continuous latent variables too. Mplus just gives them to us. And then we can use on statements and with statements and whatever. Or if you want to do various kinds of longitudinal analyses, or with longitudinal implications, survival analysis with latent frailties or liabilities. If you're familiar with that logic and those terms, then Mplus represents those with continuous latent variables. And you can look up examples in the Mplus manual. And we'll talk about that in a second. Mplus also allows you to work with discrete latent variables, categorical latent variables. It's kind of a form of cluster analysis or latent class analysis. And we won't be doing any of that, but if you get what's referred to as the mixture add-on, then Mplus allows you to work with categorical latent variables. Which is like saying that people belong to different groups or populations, but their membership is unknown. So they need to be categorized based on observed data. And Mplus can do that for you. If you've got all continuous observed variables and you're doing that, some people call that latent profile analysis, which Mplus can do. If you've got non-continuous observed variables and you're doing that, to inform cluster membership or latent class membership, this discrete latent variable, then people call that latent class analysis or latent class cluster analysis. And this is just various forms, basically, of what's also called finite mixture modeling. That can include latent transition analysis, etc. Mplus can do all of that. We won't be doing it here today, but if you get the mixture add-on, Mplus allows you to do that.
Would we be able to handle cross-classified models as well as relational databases?
Yeah, so Mplus does allow cross-classified models, but wait, do you mean multiple latent?
Yeah, multiple
discrete.
multiple membership of them.
Yeah, exactly.
Relational databases.
Well, there are a couple of different ways if you're talking about latent discrete variables to think about cross-classification, and that could be with two latent discrete variables that people get clustered into, or the data itself could be with an observed variable cross-classified, and Mplus can do that too in kind of in a multi-level model or a random coefficient model.
Two or more.
Just two kinds, like group membership and something else. Yeah, just two kinds. Yeah. Don't worry about that. Let's move on. So we'll be working with continuous observed variables and continuous latent variables. But Mplus will allow you to do latent class cluster analysis, finite mixture modeling, things like that, with discrete latent variables. Okay, so some of the features. Mplus allows you to work with a variety of different kinds of observed variables, with various kinds of distributions. We're going to assume, for the most part, continuous observed variables, but you don't need those. We'll assume continuous normal, but Mplus also allows you to work with skewed variables, or t-distributed variables if you want. It also allows you to work with categorical variables, and like count variables, for example. They could be ordered categorical, like first place, second place, third place, fourth place. Fourth place doesn't win the race. And they could be nominal variables, like if you're working with a race variable, for example. Nobody's more or less than each other. It's not even ordered. And so you can work with those variables as well. You can work with count variables, right? So Poisson distributed variables. So you're counting the number of times something happened, for example, in a specific time frame. That's the classic Poisson distribution. And those could also be zero inflated. You can get a lot of zeros. Does anybody know what Poisson was doing? This is a funny little bit of trivia. What Poisson was modeling when he came up with that distribution in 1835 or something? What it was, the phenomenon? Like high zero, what's that? Uniform? It was the military. My understanding of it is that they wanted to model the French military wanted to model or treat or predict, or maybe it was just him, but it was how often soldiers were kicked in the head by a horse while they were like changing the shoes. And that's a very low base rate phenomenon, and it's a count, discrete variable, right? So how often was that happening in a specific time frame? And he came up with a Poisson distribution to model that. Can you imagine that? Changing that thing. Your life already sucks. Because it's 1835, and here comes this guy. Number 4. Number 5, that's 5. 4 suckers. Okay. And the way that it does that, is it varies the linking function that it uses when estimating effects, right? So if you know about using categorical variables in logistic or probit regression, then really all you're doing is changing the link. It could be a logit link or a probit link, and Mplus allows you to use either. It has defaults that it will use for you, but you can go into it and modify it. So a lot of the stuff that we'll be doing can be done with discrete variables. Categorical variables, ordered categorical variables, count variables, nominal variables. We won't do that, but Mplus can. And it's very easy to tell it to, under some variable command, you'll just say categorical is, and then you'll give the name of the variable. And then that's it. And then you can just use that variable in on and with statements, and Mplus knows what to do. There are some limitations, obviously, but anyway, we're not going to go into it, but know that you can do that. It also has a wide variety of different estimators. We're just going to work with maximum likelihood and Bayes, mostly maximum likelihood, that's the most common one that gets used, but it's got a variety of different estimators, unweighted least squares, weighted least squares, generalized least squares, and then it's got various maximum likelihood estimators that are that can be used when specific kinds of assumptions get violated, like normality, for example. It can also do lots of simulations. It can simulate data with a Monte Carlo feature. And we won't really be doing that, but you can make an entire career out of just doing Monte Carlo simulations to test the performance of different estimators, look at how different models work. It's really useful for doing power analyses, so your committee, if you're a student, or for a grant application, maybe they'll say, well, how do you know you need this sample size? You say, well, I've got my model, and I put it into Mplus, and I don't have any data, because you haven't given me the money yet. And so instead of clicking run, I just treated it like some true model out there, and I used the Monte Carlo feature and generated a bunch of data based on that model, and here's the statistical power for that sample size. So it'll allow you to do stuff like that. There are papers written describing how to use Mplus to do that. We won't do that, but it's a very useful feature. I mean, you can generate data for all kinds of things. I know one guy. He can get you the data. I mean, anyway. Sorry? Exactly, right. So, yeah, totally. So let's say, for example, we'll talk about this a little more later, but absolutely, you can use different variables, right, with different underlying distributions, all in the same model. So, and even to indicate the same latent variable, if you want to do CFA, and you've got two continuous indicators of some latent variable that are measuring it, whether it's intelligence or something else, and then you've got a discrete indicator, you can use them all in the same model. So we'll talk a little more about that later. So that's pretty cool. Okay. Yeah, maybe I shouldn't have to pay for Mplus. So, whatever. So, there is a caveat here with Mplus, and that is that one thing that a lot of people want to use in the beginning is a diagrammer. So if you're comfortable working with diagrams, I see a couple of smiles, maybe a few guilty smiles, like, yeah. The diagrammer in programs like Amos and whatever else, it can be really useful if you don't want to have to work with anything even remotely resembling an equation. Then you just draw the model, circles, arrows, squares, rectangles, whatever. But
I don't know, that's kind of like learning how to drive on an automatic. You know? What if at some point you need to drive manual? You'll never have learned. And then you're stuck. So, although maybe not anymore. That analogy is working kind of less and less well every year. But anyway, we're going to learn how to drive stick. And what that's going to allow you to do is drive every car. Because if you can, it's, again, I don't know why I went back to that. That's stupid. If you start with a diagrammer, you're not going to be able to diagnose problems and modify a model in a wide variety of ways. Mplus does have a diagrammer, but it's only useful for specific kinds of models. Really complicated models at multiple levels of analysis, the diagrammer doesn't work for those. And so the more general set of tools is going to be doing everything by hand. But Mplus makes that really easy. On and with statements, it's going to be super easy. Here's another thing to consider, and that is Mplus is really user-friendly. Very little input is required. But what that means is that a bunch of stuff is going on behind the scenes, and Mplus is making decisions for you. What estimator to use, how that estimator is actually going to function. Wide variety of different decisions will be made for you. So there's a trade-off there, right? The learning curve is not very steep. You're going to acquire a bunch of useful skills and knowledge really quickly, but know that there's a lot going on behind the scenes, and you can learn as much about Mplus as you want. So if you want to learn a lot more than we're going to learn here, look at the manual, go into the manual, and it'll tell you, it'll describe to you what's going on. Read some of the papers that I sent around in that introductory email that had the slides and everything else for the workshop. There were some links to some papers that describe the kind of fundamental underlying model and the logic there. So you can go and look at those. Each part of Mplus code, of input, has defaults. And just read the manual to know what those are. If you're just working with continuous normal variables, or you're making the assumption that you are, then a lot of those defaults are going to work really well. It's going to be really easy. But you can modify all kinds of stuff. Anyway, check the manual, read model descriptions. The manual is awesome. It's this tome, it's huge. And it's got examples of almost any model you'll want to estimate. It's got an example of the model. It'll often diagram the model. It'll give you the input code, and then it'll describe to you what the input code means. And it's got hundreds of those. It's really cool. And if you want to actually look at what Mplus is doing, there are a variety of different output options that you can request. We won't, for the most part, do any of this. But the tech options is what they're called, Tech 1, Tech 2, Tech 3, Tech 4. They all give you specialized output, like parameter matrices or whatever. You can look that up in the manual. And that can be really useful for diagnosing specific kinds of problems that you might encounter. And again, it's just more self-study after the workshop. So here's an example, which is too small, and you're probably too far away, I'm sorry. I'll just describe to you some of the basic features that you'll have in any Mplus input. So what we'll do is we'll have different input headings. And below the heading, you'll have specific commands that you'll use to tell Mplus to do specific things. So the first heading you'll often see is a title. And after a heading, a command input heading, there will be a colon. And when Mplus sees the colon and a heading that it recognizes, like title, it knows what to do with the information that comes next. So title colon is nothing. You don't have to include it. It's just basically for you. So you say, oh, this is the model that I really want to work. This will make my career. Semicolon is how you end a statement in Mplus. Once it sees a semicolon, it stops looking for whatever is there for it to read. So here's start input section with the heading and a colon, then type specific commands or options, and then each statement with a semicolon, semicolon. That is a title for that input right there. You don't have to put anything there if you don't want to. You don't even have to include title. This is mostly for you. If you want Mplus to ignore something, you want to make a note for yourself in the input, you put an asterisk, and then type anything you want. And we'll see how Mplus treats that. It'll turn it green to let you know, I don't care about that. So that's just for making notes for yourself. The next heading is data, and this is where we tell Mplus about our data, where the file is that contains the data, and et cetera, et cetera. You'll see how it all works. Under the variable command, we'll describe the variables that we're going to use. We'll give them names, and if we have any additional information about the variables, like for example, if some are categorical, then we'll tell Mplus there, oh, this variable is categorical. Well, some special functions there we'll go through. The analysis heading tells Mplus what kind of analysis to run. There you can tell Mplus what kind of estimator to use. Oh, I want maximum likelihood. Oh, I want a Bayes estimator. The default is maximum likelihood. You don't even have to include that. We'll see how it works. The model command is kind of the meat of the input, to the extent that that's where you basically take your theory about the world and turn it into Mplus code. Your rules about the world. We'll use on statements and with statements. We'll get our regression coefficients, covariances, etc. And then under output, we can request various kinds of output. If you're in psychology, you almost always want standardized output, don't you? You want to report those. Reviewers will always say, what about the standardized coefficients? You say, okay, Mplus, give me the standardized output. If you're an SPSS user, that's the beta weight it'll give you if you request standardized output. So we'll see how it all works, don't worry. So there are a bunch of different input headings, and there are different chapters in the manual devoted to each one. So you can just open up the manual and go to these different chapters, and you can read to your heart's discontent. And then, you know, really, really treat yourself. Run yourself a bath, put some bath salts in it, you know, open up a bottle of wine, a nice one. And then get that manual. Oh, God. Ah, what an evening. Okay. So, again, title is kind of irrelevant. What does really matter a lot is the data heading. So Mplus is not like SPSS. It's not like the newer versions of Stata, which are basically like spreadsheet programs, aren't they? They look like Excel. When you open up Stata, it shows you all the data. And how do you open up, SPSS? When you do Stataviz too, I guess, these days. Oh, no, it doesn't. Yeah, indeed, it doesn't. It will if you click the button at the top, but the first thing you see is just the input. Yeah. But SPSS, how do you open it usually? You don't open SPSS, you double-click the data file, don't you? That's how you tell your computer to, hey, run SPSS. And then what does it do? It shows you the data. So SPSS is basically an Excel spreadsheet program combined with a stats program, right? It's got all the estimators, all the algorithms for estimating everything. It'll give you the output, etc. But it's also got that spreadsheet function. Mplus does not have that spreadsheet function. It is not an Excel program mixed with a stats program. It's just stats. So what we're going to do in Mplus is we're going to type out input code, which is going to be super straightforward, I promise. But because it's not a spreadsheet program, it doesn't know where the data are. It doesn't have the data already loaded. They're not sitting there waiting like in an Excel spreadsheet style that it knows to act on. So what you have to do is you have to tell Mplus where the data are. It's going to read the input file from more or less top to bottom, and it's going to start with the data. It's going to say, hey, here's the data. Well, you can mix it up, it doesn't matter. But it'll look first for the data. Where are the data? Well, you have to tell it where the file is that contains the data. And then it'll go get the data, it'll fetch the data, it'll load the data into memory, and then it'll perform all the operations on those data. So you don't have to type out like, the root directory and everything else. You can just say the name of the file, as long as the input file, the Mplus file, is in the same folder as the data file. And you'll see how it all works in a second. There are a couple of different kinds of data formats that Mplus can work with. The default is just regular data with kind of, what we'll call individual data, which is the actual observed cases that you have, all the data. But you can also use summary data as input. Variances, covariances, means. You can just use those as input. We'll see how it works in just a second. And then you'll have to tell Mplus, I'm working with summary statistics. I'm working with summary data. The default is individual data, bless you. Mplus requires numeric data only. So maybe you're used to working with string variables, and those are in your data sets, but they cannot be in your Mplus data set. It doesn't know what to do with string variables, so they have to be numbers. You can also use like asterisks, an asterisk to indicate like missing data or something like that. I always use a numeric missing data flag, and typically -999, because I'm not in accounting or some field where maybe -999 appears every once in a while. But anyway, so you can have missing data flags, but they can't be words. It can't be like, what is it in R typically? It's like NA. There you go.
So Mike, what happens, how does it treat the missing data? Does it pairwise delete or?
Oh, so we'll talk about that later. There are various other options allowed. You can see the manual. So let's get an example of what individual data look like. Well, it just looks like whatever the data look like in SPSS or Excel or whatever, right? In Mplus, the input typically, just by default, it'll work with tab delimited data or data in the CSV format, comma separated values. And so if your data aren't in that format, if they're in SPSS, an SPSS file or an Excel file, just go to Save As and then change the file type to CSV or tab delimited, which is .dat or .txt, depending upon whether you're using Excel or whatever. And then save the file in that format, and then later, yeah? Or were you waving to them?
Yes.
Oh. Right. I'm with the late people, she said. Yeah, right, exactly. Welcome. Okay. And that's everything. So thanks for coming. And I mean, who knew we could compress it all into that amount of time?
So it'll take an SPSS.dat file.
Yeah, exactly. If the .dat file is tab delimited, right?
So you have to save that as a tab.
It has to be, well, it has to be in a tab delimited format or a CSV format. But you just can find the save, save as tab delimited or CSV. There are a couple of different tab delimited formats, and like in Excel, and I think just the standard one works well.
Just point out that when we move it from SPSS, there's probably a few sets that when you move it into convert it in SPSS, it puts this really, really weird set of 3 characters.
Oh, right.
Left.
Yeah, it does.
Just a trap for people.
Just a trap.
They might run. Everyone runs.
Right.
So you can open it and delete the 3 characters.
Right. So what he's saying is that when you save it from SPSS in a tab delimited format, even in CSV,
I don't know about CSV,
but tab delimited,
yeah.
for whatever reason, in the very beginning of the file, there are like 3 weird characters. But if you open the file in like a text editor on your computer and just delete those 3 characters and then save it again, then it'll work.
Yeah, you can open it in Mplus. You just go to the file.
Oh yeah, right. You can even open it in Mplus.
If you don't delete them, then
And what a simple little stupid problem that will make the whole machine grind to a halt. Yeah, exactly. Okay, so the data have to be in tab delimited or CSV format. This throws some people who are used to working with just like an Excel, like a spreadsheet program, but Mplus isn't that. So each variable is a column separated by tabs or commas. Missing data will have some flag. If you have missing data, we'll talk about how Mplus treats those in a second. Well, if Mplus doesn't only takes numeric values as input for the data, where are the variable names? Well, they can't be in the file. So when you save the file under SPSS, it's got a little radio button or box or checkbox or whatever that says save variable names or something is like the first row, and you have to uncheck that. Otherwise, it'll print the variable names across the top, and then all of a sudden, you're sunk, because Mplus will have problems loading the data. The variable names are something you tell it later under the variable command. So we'll see how it all works. How about summary data? Well, it turns out that because if you make assumptions about your variables being normally distributed, right? Continuous normal distributions. Well, what do we know about those variables? How many parameters do they have? They have a mean, they have a variance, and each unique pair of variables has a covariance, right? And that's all the information you need about those variables. Statistically speaking, they're sufficient statistics. Well, we just saw before you could actually do regression by hand as long as you knew what those values were. You could compute beta weights, you could do all kinds of stuff. And the same is true for M+. You can just feed it summary statistics. You can give it means, variances, and covariances, or correlations and standard deviations, whatever, as input. There's a specific format for that. And you have to tell it the order of the data when you do that. So under the data command, you would say type equals, or type is. Those are equivalent statements, an equal and an is, an equals and an is. Means, for example, might appear first in the data file. Then standard deviations might appear next. And correlation. So that would be a correlation matrix with standard deviations and means. So how many of you, if you're in psychology, how often do you see that in journal articles? Constantly. And if you don't, if table 1 isn't descriptive statistics, what does a reviewer do? They're like, oh, where are the descriptive statistics? So you gotta put it in there. So what does that mean? That means that if you make assumptions about the nature of the distribution of their variables, which is really the only reason to report those summary statistics, otherwise the variance doesn't, the correlations don't really mean anything. Well, they don't mean the same thing. Anyway, you can just lift the data out of a paper and start running models on those data, because M+ will take that as input. But because you don't have the original records, the individual level data, you need to tell M+ how many observations you have. So there's a statement, n number observations, and then you just tell it how many. We'll see how it works in just 1 second. We'll see how it works. We'll see an example of it, and we'll analyze the data. Okay, so again, where are the variable names? They're not in a data file that would look like that, where the first row means the second row is standard deviations, and then we have a correlation matrix. The variable names will tell M+ later. So watch, let's actually look at what these data look like. So find day 1, session 2, the folder under examples. So let's get out of this. Let's go, whoops. Let's go to, ow. I closed it out, hold on, sorry. Courses, M+, 2019. Examples. So day 1, session 2, the folder under examples. And it contains M+ input files and individual and summary data sets. So there it is. Oh yeah. And I always do that. I always go into the actual folder as opposed to opening it up through M+. So let's go to the individual data example.inp, or you can just watch it up here. And sorry, let me zoom in. Every year. It's too small. Is that better? So we have a title. It's just bogus text. It doesn't matter what's there. You can see that M+ is recognizing the command headings because they're in blue. The title, bogus M+ text. The data, colon, file is, we're telling M+ what the name of the file is. File is individual.dat. Well, there better be a file called individual.dat in the same folder as this input file. So if we go back to, good Lord. If we go back to this, and we've got file format, we'll look at all files. Let's open up individual.dat, which is in the same folder. And that better look like individual data with no variable names at the top. And there it is, tab delimited data. Look at those data, raw, juicy data. Oh, I see tenure and fame in there, do you? and a bunch of negative values. But you can see there that that's basically what your data set will look like, something like that. So we've got 3 columns, so we should have 3 variables. No variable names, and no letters anywhere. No letters. Okay, so that's an individual data set right there. Those are the data. So we'll talk about the other things in a second. Now let's go to the other input file, summary example.inp, in that same day 1 session 2 folder. Has everybody got it up? Or any of those who wish to have it up? Do you have it up? And here we've got same bogus title, but now we've got file is summary.dat. And we've got a bunch of other information. We have to tell Mplus, if we're using summary data, summary statistics, we have to tell Mplus what kinds of statistics we have. If we have means listed first, we'll say means. And then if we have standard deviations listed next in the data file, we'll say ST deviations. And then if we have a correlation matrix, next we'll say correlations. If we had a covariance matrix next, we would say covariance. So there are different input options for different kinds of summary statistics. Number of observations. This is just the N, the sample size, right? So if you're working with summary data, you don't have the sample size in the data itself. It doesn't know, so you have to tell it how many you have. Who wants small p-values? Well, just put a 1 or a 9 or a 9999. Now you'll get tenure for sure. Okay. Bless you. Right before you get fired for misconduct. Okay. Let's look at the summary.dat file. So if we go to all files, and we can look at the actual summary data. This is just an example data set. What do they look like? Not much there, right? If we have 3 variables, how many means do we have? 3. If we have 3 variables, how many variances or standard deviations do we have? 3. So the first line is 3 means, separated by tabs. The second line is 3 standard deviations. And then the third line is, if it's a correlation matrix, the diagonal is 1s, because all the variances are 1s, been standardized. And then what falls below that are the correlations among those variables. So if you're in psychology or another field where table 1 is always descriptive statistics, you can basically just cut and paste those descriptive statistics into a data file and then start analyzing those data as if they were your own. It's a great way to make friends, publish critiques by borrowing their table 1. I think that kind of thing used to happen a fair amount, I don't know, when this technology was kind of new in the 80s. It's less common these days. Usually these days you just ask the people for the data. Okay, so that's a correlation, those are correlations, describing the relationship among the variables. Okay, does that make sense for the data, for the little data bit? So you see how it works. Basically, you just need to get the data into Mplus and tell it what kind of data it's dealing with. That's it.
Now, for the summary data, how sophisticated of analysis could you do with that?
Well, anything that requires the raw data, obviously, you can't do. So you can't do moderation or moderation analysis or interactions, because that requires multiplying the variables together. You need higher moments of those distributions, basically. Yeah, so not very. But if you don't care about that, if it's just some path model with a couple of arrows, you can replicate that. Okay, so that's the data command. The most important thing to know is Mplus is not a spreadsheet program. So you have to load the data first. What about the variable heading? What do you tell Mplus here? Well, remember, the variable names are not in the data file. So you have to tell Mplus what you're going to call the variables. It doesn't matter what you call them. You can call them X and Y and Z, or you can type out WB. You can say, oh, the name is WB for well-being. or NA for negative affect or negative affectivity, or whatever. The names are arbitrary, but what does matter is how many names you tell Mplus you need to describe the data set. Because if the data set contains information about 3 variables, but you only give Mplus 2 names, then when it goes to the data file, it says, oh, first piece of data, that's variable 1. Second piece of data, that's variable 2. Third piece of data, that's the second case for variable 1. Because I've only got 2 names. So I'm only looking for information from 2 variables. So if you have 3 variables in the data set, you better give Mplus 3 names for variables. Then it knows, look for 1, 2, 3 records, that's case 1. Look for 1, 2, 3 records, that's the second case. So again, the names could be anything. And the command we'll use is names are. Names are, and then whatever comes after that, those are the variable names. And just know that if, for example, well-being measured whatever way, if that's the first column in the data set, that better be the first name right there in that list. Because whenever you reference that, whatever variable gets the name that gets listed first, whenever you use that in the models, in your model later, it's going to be using the first column of data. So the order matters and the number matters, but the actual names don't matter. Does that make sense? Yeah, go ahead.
Is there a number of character limits?
Good, right, excellent question. Yeah, this is written along a while ago in Fortran, and 8. 8 is the number. What a bummer. No spaces. And no spaces. Underscores. Underscores instead of spaces. No hyphens or dashes. Underscores, letters, and numbers. Nothing over 8. What's that? It's not case sensitive. Good question. Thanks. Not case sensitive. So you can have it all in uppercase in the names bit, but then in the model statement, when you start referencing that variable, it could all be lowercase.
Number of variables.
Number of what?
Variables.
Number of variables? I think the limit is like 5,000 or 10,000. I can't remember, but it's big. It's a lot. And if you exceed that limit, just break the data set up into a smaller. And what else? You actually can use, the number of characters can be longer than 8, but Mplus will truncate it in the output. So it'll know how to work with it when you're doing in the model command and everything else. But the problem is if you have variables that are named, well-being, all one word, variable 10, variable 11, variable 12, well-being 12, well-being 13, well-being 14, it's all going to be, well-being, well-being, well-being. In the output, you don't know which variable it is that it's referencing in the output. So try to keep them down to 8, and if they exceed 8, just make sure that the first 8 characters are unique. So you can always spot it in the output what the variable is. Yeah.
You only get 99 characters, 99 per line.
Oh, yeah. We'll see that too. I think it's 80.
What happens if you're naming variables?
You just go, hit enter. So Mplus also, because it's based on kind of old technology, in the input line, once you get to 80 characters, it'll stop recognizing what happens after those. So just a carriage return to the next line, and it won't stop reading until it sees a semicolon. So just know that a semicolon ends a command. And you can skip 50 lines and keep typing, and then the semicolon ends the command. Boy, these are really good questions. This has never happened in all the years that this many good questions just about the variable command were asked. Yeah, they're super important. Yeah, and it's this crap. Yeah, exactly. Okay, so names are, so hopefully it's not a problem at all. And it won't be a problem for us the whole time because obviously I've run all the input before the workshop. If you have weighting variables, a lot of you will be using data sets where you have, sampling weights, probability weights. You can give Mplus information about which variables in the data set are weighting variables if you want to use those here. There are many other options, and we'll use only some of them. But again, get that manual. Better be a big bottle of wine. Or just really strong tea. So, better be some strong tea. So the next heading is define. And so even though Mplus is a spreadsheet program, it offers you various functionality for modifying the data in various ways. So if you want to create new variables, you can do it under the define command. Define : and then you can create new variables. So for example, if you do want to, look at moderation or test interactions, you're going to typically what you do is you multiply two variables together, right? You create their product. Well, if that variable, the product, doesn't exist in the data set, you can define it under the define command. Define a new variable, and you'll just give the name of the variable on a line, the new variable, like, xz equals x times z, x asterisk z, semicolon. And then Mplus says, oh, there's a new variable xz, and it's equal to the product of those two other variables. And then you can use that newly created variable. It doesn't get saved to the data set. It's just created just for that model run, and then it'll use it in the model, if you use it in the model. There are various logical and arithmetical operators that you can use. Simple things, addition, subtraction, multiplication, division, logarithms, blah, blah, blah. But also the logical operators can be useful, because you can construct, for example, a number of dummy variables from a single factor variable, right? So if you've got a nominal variable, maybe it's race, maybe it's experimental condition, whatever it is, you can construct, whatever the number of categories are minus 1, dummy variables to use. You say, if this variable equals 1, the observed variable equals 1, then a new variable equals 0, etc. And then you can construct a number of dummy variables using that kind of if-then operation. Or you can do it in Excel, or you can do it in SPSS before you export the data. Anyway, there are logical operators. And there are transformations you can perform of some specific useful kinds. Like, for example, if you want to center some of your variables. Grand mean centering, subtract the mean of the variable from all of the cases. Then you can do that. Group mean centering, which we'll talk about later, can also do that, which takes the group mean and subtracts it from all of all the observations along a given variable. You can also compute group means or cluster means. You can create sums, means. You can do various things. So go ahead and look that up on your own. We'll use only some of those here, but there are a lot of different options under define. It's basically transforming the existing data in some way, creating new variables to use later. Under analysis, that's where you tell Mplus what kind of analysis you're going to do, what kind of estimator you're going to use, for example, the type of model you're going to use. If you're going to estimate a multi-level model, you have to tell Mplus that, because it's a very different way to treat the data. So you'd say type equals or type is two-level, for example. That's what we'll be using. And there are various other options. If you want random coefficients, like random slopes, then you'll say type equals two-level random, semicolon. We'll see how it works. But the point is that the kind of model that you're going to analyze can be described here. You don't have to type anything. If you're just doing path analysis or structural equation modeling, you'll see that you don't even need to include an analysis heading. The default is single level of analysis estimated by maximum likelihood with a bunch of defaults, but you can modify that. Okay, this is also where you can specify that you want to do some bootstrapping, which is a very convenient feature Mplus has. Under analysis, we'll use it quite soon. We'll start using it tomorrow. We'll just say bootstrap is or bootstrap equals 10,000. And then Mplus will bootstrap your model 10,000 times and give you some relevant, specific kinds of output related to the bootstrapping. If you have specific linking functions that you want to use for non-continuous observed variables, you can use those here, specify those here. There are a bunch of different options. Check it out in the manual. Okay. So I haven't completely eliminated some of the, remember when I mentioned that the whole workshop used to start with model estimation and whatever else. So I haven't completely eliminated all of them, but I've minimized it down to like 2 slides. And I just want to give you some information about what you could study just these topics for years. You could give multiple week-long workshops just on these topics. But because we're going to be switching between different kinds of estimators, I just want to give you a little bit of kind of preliminary information on the logic of those estimators and why we're going to get slightly different kinds of output when we switch estimators. If you want to tune out, you totally can. Again, Mplus doesn't care what you know. It just cares what you type before you click run. So classically, statistics in the social science have been a particular kind. What people have, what you might call frequentist statistics. It's a very specific theory of probability underlying frequentist statistics. If you've ever looked at standard errors and p-values and reported those, then you're using frequentist statistics. And you probably never even heard that term. Nobody explained to you that one of the reasons why statistics is so confusing is because of this theory of probability that everything ends up being based on. And typical estimators like ordinary least squares, regression, and maximum likelihood are based on this theory of probability, a frequentist theory of probability. It's a very specific way of reasoning probabilistically. And they used to go into that theory and its history and whatever, but if you want to look it up, go ahead. The basic idea is that this is a theory of probability wherein probabilities apply to events. Probabilities apply to repeatable events. So when I say, for example, that the probability that a coin landing heads is 0.5, it's got a 50% chance of landing heads. Under a frequentist theory of probability, what I mean is, if I flip that coin an infinite number of times, how often would the event, the outcome, be heads? And it's half if it's a fair coin. That's the idea. So that's the theory of probability that these estimators are based on. It's what would we see in the long run? How often would something happen in the long run? And a probability is always just a relative frequency in that sense. So that's the basic underlying idea. And that's why things like standard errors are so confusing and p-values are so confusing. Because the formal definitions then get linked to, like, what if a study were repeated an infinite number of times? How often would you see this estimate of this parameter? How often would it differ from 0 just by chance if you did it an infinite number of times? And then p-values and stuff get linked to that, and students are like, oh, what the heck are you talking about? Anyway, whatever. Just know that it's a very convenient theory of probability because it allows you to do all kinds of things, like make assumptions about what will be seen in the long run if things were repeated an infinite number of times. You get limit theorems from that, etc. Anyway, when you use maximum likelihood, what it does is, based on that theory of probability, it tries to give you the best estimates of unknown parameters based on the data. And that's an iterative process of finding parameters that have the highest likelihood of explaining the data. So it's a weird theory of probability because probabilities don't apply to parameters. They apply to data. How often a coin will land heads, for example. So what they do is they're basically trying to give you parameter estimates that maximize the probability of observing the data that you've actually observed. So the probability still applies to the data. And that's a maximum likelihood estimate. When you get it, when you say use maximum likelihood estimator, it's giving you the estimate that's the best explanation for the observed data in a probabilistic sense. And it does that iteratively, and it stops that iterative process when it gets close enough. When the change in the estimate becomes small enough that it says, it's close enough, close enough. And then we say it's converged, it's reached convergence, and it gives you the result. Now that's, you can change the convergence criteria, you can adjust all kinds of things in Mplus. For this workshop, we're just going to use the defaults, and you don't even have to know anything about probability or anything else. Just know that whenever it's a maximum likelihood estimate, it's giving you its best guess for what an unknown parameter is, like a regression weighted slope, based on the data. Okay, and from that you get standard error estimates and p-values and all kinds of other stuff. Confidence intervals, etc. But here's the problem with estimates like this. If I lock you in a room for a month, and I don't know why this is the example, but if somebody else locks you in a room, I'm not doing it. If you lock yourself in a room for a month and you don't know what's going on outside and you don't get any news, and somebody says, hey, what's the weather like out there? Well, how good is your estimate going to be? It's going to suck, right? It's going to be quite bad. It's going to explain the observed data of what's actually going on out there quite poorly. So that might be, whatever you say in response to it, it might be your most likely estimate. But it's still a bad estimate. So in the same way, Mplus can give you the most likely estimates for slopes, regression parameters, whatever it is, but they can still suck, right? They could still not explain the data very well. They could be the best estimates that it can give you, but they can still not fit the data very well. The probability of the observed data given the best estimate can still be low. So don't get too carried away with this term maximum likelihood, because the maximum likelihood estimate can still not be very likely. And that's why we'll look at things like model fit indices and whatever else that'll give us some indication of whether or not our estimate is very good. Even the best estimates can be bad, right? Financial crises and stuff like that make that very clear. And this is why we'll look at fit statistics. So it's the best estimate that we can get, but it's not always very good. And we'll have various ways of dealing with that. Okay, well that's a maximum likelihood estimator. It's really working with probabilities that relate to the observed data. What would happen in the long run is the way we think. But there's a different way to think about probability, right? What if I ask you, what's the probability that it will rain tomorrow? Well, if you don't know anything, you might say, 50-50, 50%, 50% chance. Well, what is that? That can't be a frequentist probability, can it? Because there is no in the long run. It either rains tomorrow or it doesn't. The probability is 0 or 1 under a frequentist description. It's never 50-50. You can't flip tomorrow's weather like a coin toss an infinite number of times. It happens or it doesn't. Well, when we use probabilistic statements in relation to, for example, one-off events, what are we referencing then if it's not what would happen in the long run? It's like we're referencing belief, or maybe knowledge, something like that. But it's not the event itself. It's a subjective, the idea is that it's a subjective kind of relationship that you have with an event, for example. If I say, hey, anyway, that's the idea. So there's a whole theory of probability that some people call a Bayesian theory. That's kind of, philosophers would dispute that because there are a bunch of different ways of understanding this kind of probability. But all of them that are kind of in this category, they rely on Bayes' theorem to estimate probabilities. And it's a specific way of reasoning about probability that is translated into a mathematical equation, a really nice one, that is often called Bayes' theorem. But the idea here is that we don't just use the data to get our estimates. Because whenever we give an estimate, or whenever we have some understanding of how likely or probable something is, we don't start with no knowledge. We start with something. We start with some prior belief when we look at data, and we update the prior belief. That's the idea. So if you ask me about tomorrow, if it's going to rain, I say, well, I haven't looked at the weather today, but here's my probabilistic belief, and I say 50-50. And then you say, okay, now go out and look at the weather. And I go out, and it's rainy, foreboding, there's a gale, whatever. And I update my initial probability about what's going to happen tomorrow with the data. And that is a kind of what you might call a Bayesian updating. So for this style of probability, under this theory of probability, we have prior beliefs, those are probabilistic, and then we take those and we basically mix them with the data. It's a sloppy way to describe it, but maybe useful. And the result is what we'll call posterior probabilities or posterior beliefs. And Mplus does this automatically if you say use a Bayes estimator. What it does is it estimates the probability of parameters for you based on priors and the data. Now the priors are actually probability distributions, and you can specify those yourself if you want. You can go in and manipulate it. But Mplus has a bunch of default priors that it uses that are called uninformative, or there are a variety of different names for these kinds of priors. And the idea is that they make the priors irrelevant. They try to make the priors irrelevant. And so all you're doing is estimate, you're doing estimation based only on the data. And if you're doing that, then results should match the maximum likelihood estimates, because those only use the data. So anyway, that's kind of the long and the short of it. Mplus will give you results if you just click run, and yeah.
What's the point of using a Bayesian probability if you don't specify the prime probabilities?
Well, if you want to be practical and not just have kind of pseudo-philosophical debates about what the right theory of probability is, which in philosophy it's a big deal. I mean, epistemology in the 19th and 20th century was to a large extent a debate over this kind of stuff. So, so it was a huge deal for them, but practically for us, Bayes estimation has a couple of different benefits. If you do want to work with prior probabilities, you can incorporate them into the analysis. So for example, instead of having to do an entire meta-analysis, redo a meta-analysis whenever somebody publishes a new study on a topic, if you take the prior meta-analysis and all the findings of the previous studies as priors, and just chuck the new data into it, what you get is automatic synthesis of all results on a given topic, for example. So people talk about it being useful for that. I don't actually foresee the average customer, you know what I mean, like the average researcher doing very much of that. But what we'll find is that Bayes estimation can be useful for getting results when maximum likelihood estimators fail, when you run into problems for one reason or another. For example, when variances get close to zero, Bayes estimation can sometimes work when maximum likely estimators can't. Okay. The way this works is different than maximum likelihood. It uses something called Markov chain Monte Carlo estimation. Basically what it does is it has two different, what it calls chains, what we'll call chains. These are basically just iterations where it's estimating parameters separately for the model, separate estimation, separate. And then at the end, it looks for agreement between those two chains. And if they agree, then it says, oh, it looks like we've achieved convergence. And then it stops estimating and it gives you results. That doesn't mean, just like maximum likelihood, just because these two things agree doesn't mean that the estimates are good in terms of fit to the data. It just means it's done. That's kind of all it means. They're the best estimates that it can give you. So we look at very specific kinds of fit statistics. They're different. Again, a lot of this stuff isn't normalized in most social sciences because statistics has always been frequentist, at least in the 20th century when statistics was created as a discipline. But we do have this option. And we'll talk about how to understand it as we go. But again, this isn't a stats. This is an Mplus workshop, right? So we're not, okay. What the juicy part of Mplus is really the model command. Because the model command is where you specify your theory or hypotheses about the world in a way that allows Mplus to estimate the unknown parameters that you care about, the rules that govern the world. That's the idea. It's so Judeo-Christian, isn't it? These rules. I mean, it all stems from, you know, I mean, science grows out of religion, obviously, in the 15th and 16th, 17th century. And the idea is that, you know, like Galileo and everybody else said, that the world operates according to God's rules. So you can disempower the church, and you can start not having to look at religious texts because the word of God is in the world. And so you can go through the world and investigate God's rules. So the idea that starts science is that the world is rule-based. So that's often why it doesn't work very well. Okay. Anyway, whatever. So this is where the rules go in. The rules for the world go into Mplus input. And basically, you say what to estimate, what parameters to estimate. Each model is actually an equation, right? You could write it out as a regression equation if you wanted to. But in Mplus, we're just going to use some simple statements, on and with, for example. And we'll work with diagrams instead of equations. And we'll translate the diagrams into Mplus input. But you can work between the three, Mplus input, diagrams, and equations. There's going to be some informational equivalence there. Let's see. So, for an on command, what are you telling Mplus to do? This is under the model heading. Super easy to say on, so you should know why you're doing it and what it means, and why you get the output you get when you use the on statement. Well, on is regression. So you're telling Mplus to estimate one slope or multiple slopes. That's it. Estimate a slope, rise over run. For example, y on x. If that's your input statement, y on x, that's the equation. Something like that Mplus will estimate. It's got a residual, it'll give you residual variance. It's got a slope, it'll give you the slope, it'll give you a standard error and a p-value. You can get standardized slopes if you want. In a second, we'll see how that works. And it'll give you an intercept for y, because there is an intercept in that equation, right? It's that new term. Just that basic geometry, right? Rise over run, an intercept and something else. It's our model for y. It regresses y on x. You read the equation from left to right. If you want to diagram it, you might draw it like this. And this is kind of messed up. Like the equation reads from left to right with the outcome and then the predictor. But the diagrams always go from left to right with the predictor and then the outcome. So the diagrams are usually reversed. So predictor's on the left, outcome is on the right. And that diagram gives us a bit of information about what we're doing, doesn't it? If you're comfortable with diagrams and the equations and Mplus input, you can look at the diagram and say, oh, what does y equal? Well, y equals anything that's on the other side of those arrows. Those arrows explain y. So what explains y in the equation? Y equals the predictor multiplied by that path coefficient, beta. And then what else does y equal? Well, we've just said if we see a single, it's like a Charlie Chaplin moment. We see that single-headed arrow, we know that that's a residual. That's an error term, a disturbance, or a residual, something left over. And that's in our equation too. So in Mplus, the cool thing is that Mplus gives us the entire regression equation. It gives us the entire diagram just by typing y on x, semicolon. And with that, we've got a residual, an intercept, and a slope. Mplus will give us those things in the output. So the input code is quite simple. Does that make sense? Is that okay? We're going to do it in a second. I know this is very abstract, but we're going to start running these models in just 1 second. The other command, remember this is just an intro to the Mplus logic and language. The other command is a with command, and that refers to a covariance. Different fields use different symbols to indicate covariance. Sometimes you see it as a psi, sometimes you see it as a theta, but whatever. whatever it is symbolically. And Mplus, if you want to estimate a covariance, you have the two variables and a with statement between them. Y1 with Y2. That says, hey, estimate a covariance there between those two variables. And we can diagram that in a couple of different ways. If we're working with observed variables, Y1 and Y2, and we say with, then we would diagram it like that, the top one, because they're squares or rectangles, so we know they're observed variables. Jesus Christ. Yeah, that's fine. Either way, as long as someone's laughing. If we're working with latent variables, we would just diagram them differently. We'd just draw circles or ovals, and then you know they're latent variables. But the cool thing is that in Mplus, it doesn't care whether the variables are observed or latent in terms of the with statement. You'll still just use with. A1 with A2. And it doesn't matter how you symbolize the covariance. Maybe you want to draw a little theta there because you and your buddies, your pals, use a theta for covariance. Or maybe you use a psi or something. It doesn't matter. It's just a with statement in Mplus in the model. The important thing is getting the data, using the actual with command, and interpreting the output, which is what we're going to do for the rest of the time. We'll not get the data. We've got the data. Okay, and there's one last major command in Mplus that we'll use, and it's a by command. And that command indicates we're going to work with some latent variables of a very specific kind, like factors in factor analysis. That kind of a variable. And by is a cool term to use to kind of invoke a latent variable in the following way. We're going to say, if a variable is latent, is it observed in the data set? By definition, no. So under the names are command under variable, there is no name for that variable, is there? Because it's not in the data set. So we got to make it up as we go along. It's a cool thing about latent variable modeling. You're like, oh, well, here's something, and now for something completely different. Here's any Monty Python fans out there. So what you do is, when you invoke a latent variable for like factor analysis in CFA or SEM, we'll use the by command, and the way it works is like this. The name of the new latent variable comes first. You can call it F1 or anything you want. And that gets defined by, it has to be indicated by some observed variables. You have to have real data somewhere that give you information about the latent variable. So the latent variable is defined by some observed indicator variables, typically afterwards, semicolon. They don't even have to be observed, they just have to be indicator variables. We'll see. Higher order factor models and blah, blah, blah. The point is that in Mplus, you have to tell Mplus that you're going to create a latent variable, and the term you use for that is by. The new latent variable is indicated by some other variables, semicolon. And now you're doing confirmatory factor analysis, as we'll see soon. You can label it anything you want, F1, whatever. But here's the interesting thing, as we'll see. We're going to talk a lot about this later. I just want to tell you the word is by. We're going to talk about latent variables, how to understand them, how to model them, etc. day after tomorrow. So if you have questions about that, good. You probably should if you don't know very much about it. And we're going to address it all on Wednesday. Do you still have a question?
I'm sure this is my first time.
Okay. Go for it. Yeah, what is it?
I guess it's very simple. Can you define a latent variable with another latent variable?
Yeah, exactly.
So,
Exactly. That's kind of why I corrected myself when I said by observed indicators. The indicators could be other latent variables, but somewhere there have to be some observed variables somewhere. Yeah. So yeah, exactly. So you can have latent variables to the right of it, but then those latent variables are going to need their own by statements. Okay, and here's the interesting thing. That's actually just a regression equation. Because what you've got now is you've got factor loadings. We'll talk more about this later. but it's all just regression. It's like saying, hey, the observed latent variable loads on these observed variables, is connected to them with slopes, rise over run. We'll call those lambdas. Just to keep in our head, oh, those are factor loadings. Those aren't regular old betas, but they're still just rise over run. We'll talk more about it later. Promise. Like a lot. A lot. Yeah.
That would include talk about why the first loading
Is 1. Yeah, absolutely. We'll definitely talk about that. For like 5 or 10 minutes, that's going to come up. Okay. So, every once in a while we'll use typical SEM notation for relevant vectors and matrices, and Mplus uses it. It uses it sometimes in the manual. It uses it in the Tech 1 output that gives you the parameter matrices. We won't rely on these very much, but you should know that there are specific standard notation that it uses, and it's common in the structural equation modeling community in education, psychology, and elsewhere. And those are as follows. All of these basically just get populated to tell Mplus to either estimate an unknown or to not estimate an unknown. And what are those unknowns? Let's go to the next one. Well, big B is a matrix of beta weights. Those are typical slopes in regression equations. Lambda, big lambda, is a matrix of factor loadings with elements little lambda. Those connect our latent to observed variables. Again, we won't really go into these or use them too much. We're just going to kind of code in Mplus. It's going to be really easy. Eta is a vector of latent variables. Psi is a matrix of latent variances and covariances, etc. Theta is a matrix typically of observed variances and covariances. Nu is a vector of intercepts. Alpha is a vector of latent intercepts or latent means. And all we're doing when we use on, by, and with commands is telling Mplus to specify these in specific ways. And it does everything for you automatically. You just use the on, by, and with commands. How many of you learned literal like in the early days when you had to set up the parameter matrices with zeros and ones? What a pain in the neck that was. And you had no idea why it didn't work. It was just always like, you know, these giant, what a nightmare. And then your advisor walks in and is like, why aren't you getting that? I'm like, dude, this is, like it's the equations are easy, but Jesus Christ, I put a 1 instead of a 0. Those days are long gone, thank God. There are other specific kinds of model notation or commands that you can use, and they do some really cool things. We'll use only some of these sometimes. On, by, and with are the major commands, because those tell Mplus to estimate specific kinds of relationships or parameters. But you can modify the way it does that. You can fix parameters to specific values. You can fix 2 different parameters to be the same value. You can demand that Mplus treat them as if they're only one thing when it estimates them. So for example, if we just say at the top, y on x, that tells Mplus, give us an intercept, give us a residual, and most importantly, give us a slope. And freely estimate that slope. Make that slope the maximum likelihood estimate. And so that's a freely estimated parameter. Mplus estimates one thing. It's estimating that unknown. But if we say y on x at, we'll call that at 0.5, now we're telling Mplus, guess what? Fix it to the value of 0.5. And what are we fixing? The slope. We're fixing the slope to be 0.5. Now, is Mplus estimating that parameter? It's not. It seems like it's estimating it because it's not 0, but it's not actually estimating anything. It's imposing that value of 0.5 on the model. So if you want to fix a parameter estimate to a specific value, you can. This comes in handy every once in a while. We'll see why. Now, the whole time so far, we've just been referencing variables and variances. But what if you want to reference an intercept? Well, that's a part of the model, isn't it? Well, the way you reference an intercept or a mean is in brackets. Any commands in brackets allow you to, you're referencing intercepts or means. So for example, in a bracket, if we said y at 0, well, y is now no longer a variance because it's in the bracket. Y, if it's preceded by the y on x statement, now that's y's intercept. So now we're referencing the intercept part of the equation. Do you usually care about intercepts? When you click run in SPSS or Stata or SAS? Yeah, exactly. And that's almost a scornful one. They don't matter. Right.
Relative risk. Who cares about absolute risk?
Yeah, exactly. Who cares about absolute risk? Yeah, that's funny. What we usually care about are the slopes. Residual variances, R squared. The intercepts have nothing to do with that for the most part, right? Under specific circumstances, we will care about intercepts. And when we do, we'll come back to this in brackets. But just know that the option's there. It's part of the model, so you should be able to manipulate it if you want to. Mplus allows you to do that. Just make sure you're talking in brackets. It's like that. It's like the and then, that kind of thing. Okay, there's another kind of notation for the model command. We'll finish in just 1 second, I promise. And that is that asterisk, that little star. So if we say, for example, f1 by y, now we're talking latent variables, aren't we? We're saying, hey, Mplus, there's a new latent variable named f1. So if I say f1 later, know I'm talking about this latent variable. And that latent variable is defined by, let's pretend y is an observed variable. It's defined by y, this observed variable y. And Mplus says, okay, and then we tell Mplus, guess what? I want you to freely estimate the relationship between those variables. And because it's a latent variable, I really should use the on statement for this instead of by. But it becomes relevant in relation to by later. The asterisk just means freely estimate that relationship. Now, usually that's what Mplus is doing by default. But in some very specific circumstances, it fixes a parameter to a specific value. And if you don't want it to do that, if you want to override that default and tell Mplus, oh, you're fixing, I can see you in the output, fixing this parameter to some specific value, 1 or 0. Don't do that. Estimate it. Then you put an asterisk there and it will estimate. In this case, it's a by command, so it's a factor loading. We're telling Mplus to freely estimate that factor loading. We'll talk about this more later. Just know that this will come up. Now, there's some other cool commands that Mplus has, like the dash here, the hyphen, f1 by y1 to y5. You're a busy person. You've got lots of things to do. Children nipping at your heels. You know, advisors nipping at your ears. And whatever it is. And you don't want to have to type out y2, y3, and y4. Well, as long as in the names section of the input names are, if they're all in a row, y1, y2, y3, y4, y5, you can say y1 to y5, and Mplus will know everything in between. So that's a really convenient command. And you can combine that with some of the other special commands, like that at. If you say, hey, f1 by y1 to y5 at 1, not only are you telling Mplus that all the variables between y1 and y5 are those indicators of that latent variable, but you want to fix all the factor loadings at 1. So you can combine that kind of logic there. We'll use it. We'll use this on Wednesday. You'll see how it works. Not necessarily. And we'll talk about why as well on Wednesday. Because it's not correlations. It's raw regression weights or slopes. So you can still have residuals. Okay. So let's just get through this. What we'll also do, the next thing that Mplus allows you to do is label parameters. And this is so convenient for various things. Maybe you want a slope in a regression equation, and then you want to tell Mplus to do something special with that slope. You want to multiply it by something, or you want to divide it by something. Or anyway, it's just a parameter estimate, right? So Mplus will allow you to label that parameter estimate, and you do it in parentheses, y on x, parentheses b1, and now Mplus says, oh, whenever I see b1, I know that's the slope, y on x. So now I can take that and do other things with it, and there will be some examples of that later. So just know if you see parentheses, it's a label. It's a parameter label. But this sets up an interesting little technique here, and that is, what if you have one label for two parameters, estimates? So check it out. The bottom, y on x and z, that's saying estimate two slopes, one for z and one for x. Well, if I have just one label for both of those, that's like saying treat both of those as one parameter and estimate them not separately, but together. So provide the maximum fit to the data while constraining them to equality. So if you want to impose model constraints, where you constrain two parameters to be the same thing, two estimates, all you have to do is provide the same label. And they don't have to appear together like that. On the first line of code, we could say y on x, b1 or b2, and then the next line we could say y on z, b2, and it's the same thing. So if you want to impose parameter constraints, constrain parameters to be equal, you can do that. And we'll use it later. It's just another little nifty tool. Yeah.
If you wanted to label X and Z, you just put the brackets after X to what you want to label it as.
Right. I think you can't actually do that. What you have to do is, at that point, do it on separate lines. Yeah. We'll see. Okay, so don't worry. We're gonna put all this into action in the coming week. These are just some of the options. So what are those parameter labels useful for? Well, there's this whole section of input after the model statement. If you want, you type model constraint colon, and then you can do all kinds of cool stuff. You can take all of the labels that you had in model, and you can do whatever you want. We'll see how it all works. Blah, 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 bunch of options. For example, if you didn't want to constrain the two slopes to be equal, but you wanted their sum to be 0, then under model constraint, you would say b1 plus b2 equals 0. And Mplus is like, okay, well that's weird, but I guess if one goes up, the other has to go down. You know, they have to be opposite in sign. That's imposing that two coefficients are opposite in sign, right? If they have to sum to 0, opposite in sign and equal in magnitude. Why would you want to do that? Mplus doesn't know, it doesn't care. But if you want to do that, then that's one way to do it. I know, weird. But we'll talk about why this stuff and how it can be useful. You can see already, on by with, super easy to use Mplus, and whoa, all of a sudden you've got amazing possibilities for all kinds of specialized modeling. Okay, if you're going to do Bayes analysis and you want to modify the prior probabilities, if you don't know what any of that means, don't worry about it. But if you do know what that means and you do want to work with priors, you can specify them explicitly. Mplus by default will use a specific set of uninformative or non-informative or whatever priors. But if you want to modify them, under model priors, colon, you can do that. So what you do is you would label a parameter under the model heading, and then down under model priors, you would tell Mplus what the prior probabilities are for that. The hyperparameters, you could also say, for that. So if under model we have y2 on y1, we know that's a slope. b1 is now the slope. Under model prior, you say b1 is normally distributed with a mean of 0.25 and a variance of 1. That's kind of like cheating, a frequentist would say. Anyway, if you want to cheat. But this can be useful for various things. So if you're an econometrician, when would you use priors like this? Maybe you're a time series econometrician. You use VARs for economic modeling, and you assume you use the, what are they called, Rochester priors, or which university is it in New York? I don't remember. Anyway, whatever the priors are, they're like, they assume autoregressions of like 1, and so then the mean of the slope is 1 for the prior, and then whatever. Yeah, because they assume integrated time series, or unit roots, they call them. Anyway, if you want to mess around with priors, you can. For example, the default for Mplus's regression coefficient priors is like this. It's like if you said, hey, the prior on the slope is a normal distribution with mean of 0
and a variance of 10 to the 10th. How big is 10 to the 10th? Pretty big. What does that mean? It means, wow, it's like taking the probability of any value for that slope and saying any one value is just as likely as any other value. As the variance of that prior becomes centered around a mean, it's like more and more pulling the estimate towards that mean. Anyway, 10 to the 10th like flattens it out, and that's one of Mplus' ways to try and make it uninformative. Again, if you don't know anything or care about Bayes analysis, don't worry about it. Model indirect, we'll use this. This is cool if you like to do indirect effect modeling, mediation, modeling. Mplus makes that easy, and we'll see how it does it here. A whole input statement related to it. There are a few others: output, save data, plot, and Monte Carlo commands. They're all specific and pretty self-explanatory. If you want to plot something, use the plot command. If you're a Mac user like me, you have to access it through R, which is kind of a pain in the neck. But if you're a PC user, then the plot command just works really easily. You can do all kinds of cool stuff with the plot command. Plot posteriors and priors in relation to each other, all kinds of stuff. Mostly what you'll probably care about are things like standardized output. And so we'll see how that works. Under the output command, you just request standardized. There are a few specific features that we'll use. Save data, this can be quite useful. For example, if you're working with latent variables, but you want estimates of individual standings on those latent variables, Mplus will give those to you. It'll give you the bloops, the best linear unbiased predictor of each individual standing on each latent variable. They're called factor scores. Mplus will give you that if you want. It can spit out covariance matrices for latent variables. It can give you all kinds of stuff. Okay. So that's it. So what's our job? Well, we'll tell Mplus about the data and our estimated model, anything, any features of the analysis, any specific kinds of output that we want. We'll tell it that too. And then we'll actually specify a model using on, by, and with statements. That's mostly it, just on, by, and with. And then we'll use usually a maximum likelihood estimator by default, but if you want to, you can use a Bayes estimator. And then we'll use the results to make inferences and get grants and get tenure. And the rest of the week, all we're going to do is work with different data and models and set everything up appropriately to fit specific cases. But on, by, and with, those are the basic building blocks. Regression, slopes, covariances, and factor loadings with latent variables. For the most part, that's it. The data will become richer as we go over time, many predictors and outcomes simultaneously, etc. And the models will become more complicated over time, but we're going to start very simply, and you're going to see we're just going to slowly build on what we start with this afternoon, which will be path analysis. And all we'll have to use are on statements and with statements. And that's it. Does that sound okay? Okay. And then obviously you can go back into the manual and look at specific special features that it's got, etc. We'll see. We'll go through it, and you'll see how it works. Deal? Okay, so lunch is over there.